Hello, everybody. My name's Len Hampton. I'm with Plus Tech Inc., and we're demonstrating two machines. Our Sodick GL30A LP. LP is a super high response, like a 2 to 3 millisecond response time machine. We sell a lot of those. We range up to 500 ton in horizontal and 200 ton in vertical machines. What's special today, and I'll take you around the machine a little bit, we're partnering with some fantastic partners, really on the high end of the technology curve. We've got Matrix Tool, which is has built a very intricate tool here with a lot of micro features in the parts, and it's a real engineering grade, high temperature engineering grade material. It's a liquid crystal polymer from Sumitomo Sumika Super, running very fast cycle times, and we'll show you that as well. But running all day, we're running 12,620 cycles, very consistent, very fast fill times, right in the 1.2 second fill time, and minimum cushion you'll see is 1.3 millimeter, consistent. So that's one thing you can really get out of a Sodick machine is fill time, consistency, and dosage accuracy is, I think, of course I'm partial, but I think it's the best available. So we're also going to be, you know what, we're also going to be showing a liquid silicone rubber machine, and we're partnering with MR Mold, Rick Finney and Jerry Anderson. MR actually built the tooling and automation on this tool. So, of course, so in any event, we're running a liquid silicone rubber mold here, which has an automation in-mold slitting device, which Rick will talk about in a few minutes. But I want to bring it back to Matrix Tool. And maybe, Tom, you could say a few words about some of the inner workings of the tool.
Thank you, Len. My name is Tom Moyak, and I work at Matrix Tool. I'm the business development manager there. When we were discussing how to showcase our capabilities at a trade show, it's really hard because you can't always bring a customer's mold and run production parts at a show. So you want to make an investment and try to showcase your capabilities. Now, our company is primarily making the really intricate electrical connectors. It's automotive, telecommunications, and as everybody knows, the more time goes on, the smaller circuits get, the closer together they get, and we were starting to be challenged by traditional equipment, traditional ways of doing things with building your mold, laying out your parts in the mold, using the traditional injection molding machine techniques. So we really wanted, that drove us into the micro realm internally. So we call small parts molding because we not only have micro mold parts, but we have parts that we consider micro featured. A lot of what we do in connectors are very fine featured parts. That pushed us to look at everything basically, you know, like lean manufacturing. Apply that just like Sodick has done to eliminate waste on their machines and make things more efficient. We did that to our process as well. So we look at unique layouts in our molds to reduce flow lengths, get cavities tighter together, reduce material waste, and in doing so, reducing flow lengths, you can fill smaller runners, save material, thinner features, get all those benefits. But so we internally invested in our tooling equipment, so we have a Sodick Micro EDM sync machine. We have wire capabilities of 2 and 4 thou wire. And we wanted to showcase our tooling capabilities and our molding capabilities in a mold. So we just, Matrix Tools logo is an octagon, and the letters are MT. So what we did, and you can see it zoomed in on one of the cavities that we made, is we made our logo's shape, the octagon, and then we did a bunch of tooling features in there that are incredibly tiny in detail. There's over 60 knife edges in steel in there, and it required everything we had from a tooling standpoint to be able to make this tool. In addition, there's wall sections in here that are under 5 thousandths, 0.125 millimeters across. And if anybody is used to thinking of minimum wall sections that you can fill in a part, it's usually not 4 8/10, 4 thousandths and 8/10 across. That's what we have at the minimum here. And we're gated on one side, and we flow through from the gate end through this region that's down to under 5 thousandths. It does not hesitate or freeze like you would traditionally expect, and it's still able to continue flowing and then go through another thin region back into thick fill again. So what we're really getting at is we made a tool that is only able to run if all the pieces come together. So we couldn't do it without the fast response that Len mentioned that these machines are able to achieve, the incredible acceleration and speeds that they can achieve. But it also required our engineering and our tool design and construction techniques to be able to do it, and the material. We have the expertise. They have the expertise on the machine, but we also needed a high flow grade, a very specialty grade of LCP, and that's what Sumitomo was able to give to us with the Sumika Super. So we used one cavity to showcase the parts, but we had 3 additional cavities. So in 2 of them, we used them as advertising pieces to showcase, Sodick's name and Sumika. But we also made a little word puzzle. We showcased this a little while ago, but on the top part, I don't know if you can zoom in on that at all. But maybe not. But oh, he's getting it. You can start to see some of the etching there. Maybe put it under the scope. But there's 10 parts. It's a word find. There's 10 words in 10 millimeters there. So that's always something fun to look for in addition to that. We would normally make really small tunnel gates, but we decided to make an edge gate so that the parts could stay attached. But we've done tunnel gates under 0.9 millimeters across diameter. So under 4 thou, 3.5 thou gates so far with this type of material. So I think that's it for me.
No, thanks so much, Tom. I appreciate it. You okay on time? So you can come over to here's a little mock-up that we use, which really shows you what the inner workings of the Sodick injection unit is what's going on in there. Basically, we're separating plasticizing from dosing. We're not trying to melt and prepare material to shoot with a single screw and a check ring. So basically, this is an extruder screw. It's a stationary screw, and the material is molten. The material actually pushes the plunger back to an exact set position by the high-resolution encoder back here. When the dose is filled, then the screw stops turning and shuts off. So you have like a positive shut-off, like a needle valve on the screw side. So when you inject with the plunger, you don't have any leak back on the screw side, and a very tight tolerance on between the plunger head and the barrel. So no leak behind the plunger as well. So that's what's going on. Much less gas, much less shear developed with an extruder screw. And then, of course, the plunger delivers an exact dose every single shot. So maybe if we move over to the second machine, we'll show you the LSR silicone, very low viscosity material. And this is a 100-ton Sodick, but the LSR package. Basically the same machine, but a different injection unit, because LSR, as everybody knows, is a little opposite. So you have cold material going into a hot mold, and then it sets up that way. So we're partnering with MR Mold, Rick Finney and Jerry Anderson. Actually, MR Mold developed the automation on top as well, which has a slitting device. In-mold slitting device, which is very, I mean, these guys you really want to partner with. They know what they're doing, and they know the capabilities of what's available out there. So maybe Rick can explain a little better on what's going on with the mold build and the automation. Rick?
Thank you, Len. My name is Rick Finney. I'm the owner of MR Mold and Engineering. And when Len asked us to partner with him at at this event, we jumped at the chance because we know that Sodick makes a very fine piece of equipment. And I thought I'd show some things that maybe, and it's a little bit hard to see. I don't think the camera's going to be able to pick it up. But as Len was talking, the silicone is a little bit different animal than plastic. You know, on that machine, it's got a hopper that's got pellets feeding into the barrel, and the barrel's melting the pellets and injecting it into a water-cooled mold. And on the other hand, what we're doing is we're pumping silicone out of 5-gallon pails into a mixing device here, and then it's going through a barrel that's got copper coils, so we're circulating water around the barrel to keep the silicone cold. And then in the silicone tool itself, we have a cold runner system. So you guys might have noticed all over the place here, there's hot runner systems for sale, but this is a cold runner system. So we are circulating water through the manifold and through the nozzles to keep the silicone cold until we inject it right into the cavity. And then we're using a stripper mechanism to strip the cavities off. And as Len mentioned, we did make a robot, and it's designed to do in-mold slitting. And we're working with Len to finish developing that. But anyways, you know, one of the issues with silicone is it's not that easy to control exactly where it stays in the mold and how to eject it. It's not, you know, silicone flash is so easy that we can't use conventional components like ejector pins and sleeves and blades and lifters and so on. You know, and we're very familiar with the plastics industry. We build a lot of plastics tools as well. And the plastics industry has it easy. When you see a place that needs to have a vent, you put an ejector pin there. Well, with silicone, we can't do that. So we have to design a tool where our parting lines are in careful locations for venting, and the parting lines also help us control exactly where the parts are going to stay in the mold. And so silicone's a little bit different animal. We find it to be a little harder to build molds for. We also build molds for the plastics industry, and my guys are high-fiving each other when they get to build a plastics tool because, quite frankly, they're easier. And I don't mean to be sarcastic, and I know a lot of friends here are all in the plastics industry, but you know, when you can use ejector pins and sleeves to eject parts out, and the part reliably stays on the core every cycle, that's a real luxury that we don't have in the silicone industry. But anyways, Len, thank you very much for inviting us.
Thank you, Rick. Really appreciate your support over the years. Lastly, Dietmar Wietzenauer, we actually, he actually flew in this Nexus Servomix pumping unit, which pumps the silicone rubber up to our feed throat here. So I'd like to introduce Dietmar. Thank you so much.
Thank you, Len, that we have the chance to show here our dosing system together with this application. As Rick already mentioned, LSR has his difficulties, especially when you build molds. You have to make them very tight. The process window is very small, and you have to take care that you take the best equipment on the market, what you get to run this process stable. And it starts basically here at this mixing and dosing systems. LSR is liquid. It comes in 2 components, and you have to mix this together in a 1-to-1 ratio. And it's available in 5-gallon pails or in 55-gallon. In this case, we are using Momentive material. There are several suppliers on the market who are offering these LSR types for all different kind of applications. And what we are doing here is, so we have 2 pumps. We grab out the silicone from each pail, and then it's delivered to the molding machine. And in this case, you have to take care that you get a perfect 1-to-1 ratio. If you get here variation inside, this can have an influence of the flow of the material, of the mechanical properties, and also on curing time. So you have to take care that you mix the material very accurate. These machines we developed and bring on the market 2013. That's the first time you have seen this technology on the show in It's servo-driven. And compared to all other systems on the market, we are using screws to grab out the LSR. Unbeatable on the market. We can split air and silicon. It's a continuous process. We guarantee that there is no air going to the process, so you have no underfillings or air bubbles in the part itself. We have flow meters. We are measuring in microliter A and B, and in case you can add colorant, we are measuring in nanoliter. So we have a process data protocol. You see all these process data shown on the machine. There is the possibility to send these also to the molding machine or to grab these over USB that you know exactly what mixture was generated. That's for process documentation. So material comes to the mixing head. Everything is here water cooled, so you have here reactive admixture inside, and with water temperature of or room temperature, you prevent that the material is curing. And these machines can handle also very small shot sizes, and I'm happy that we can show this together with Sodick. They have a very unique injection unit, and it goes down to very small shots, and in this case it's difficult to handle the mixing ratio even when you have only 0.05 gram shots like this. Okay, so that's it from my side. Okay.
Fantastic. Thanks, Dietmar. We're so happy to show your Nexus system. It's fantastic. It's wonderful. Thank you, Rick. Thank you, Dave and Tom and Matrix. Thank you so much. Thanks to all our guys, our management, Kohei, Yuji Akutsu, Eiji Iwasi, our engineers, Tony Kakutani, Johnny Yamamoto, Mike Pelletier, also with Nexus. Thanks, Mike, for partnering probably 25 years, right? So if I forgot anybody, Cedric, welcome aboard, our new sales person for the Midwest. I'm sure we're going to have some good, successful years together. So, Bennett Howard, been with us 5 years. You're the best. No, thanks so much. Plastic Technology Magazine, thank you as well. So, great show. Thank you, folks. Thanks for joining us.